the last thing we really need to do with amides and esters is understand a special type of polymer, which is commonly used for things like clothing and so on, so to make fibres that we use quite regularly, so synthetic fibres called condensation polymers. In condensation polymers, one of the things you're probably going to be asked in the assessment to do is say why they're called condensation polymers. And they're called condensation polymers because when they're made from their monomers, so the starting units, when they're made, they release or liberate a small molecule such as HCl or H2O. Right? So that description is often required in an answer. So you'll see when I show you how they're made that water or hydrogen chloride gas is released or liberated. I'm going to start with polyester, probably the functional group we're most familiar with. So in a polyester, I'm looking for anything that's got a very, very long carbon chain, and periodically in it, I see this appearing. So I'm looking for the ester functional group within it. If it's got that in it, I then need to try to find patterns within that and try to see what we call a repeating unit is. So I'm going to put one up that I'm just going to arbitrarily make up. So it may not exist, but it doesn't matter. Yeah? No, you'll see in a minute, okay? Just bear with me on this. Okay, hopefully you can start seeing that this bit is the same as this bit. So it's starting to repeat itself. So what I can see in here is, first of all, yes, it's got the ester functional groups present. Here, 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 here. And this is only a little snapshot of the molecule. Of course, we would never see it this close because we can't see atoms. But this is just a snapshot. So what I'm looking for is, when does it start repeating itself? And it starts repeating itself around about here. This bit is the same as this bit. By identifying the repeating unit, I can then find the monomers, and this one's made from two monomers, the monomers that it's made from. So if I cut the very first ester group in half that I come across, the very first ester group that I meet, I'm going to break it in half at the oxygen. Okay? And keep going until I have the repetition, and you see the repetition is here. I'm actually going to take that OH off because that would actually make things go crazy. So I'm going to just leave it as that. Okay, now I can see that there's also another ester group inside this. Can you see that here? There's another ester group inside it. So what I'm going to do is I'm going to cut that one in half as well. So the outside ones create what's called my repeating unit. This is what there are N amounts of. N is a massive number. It's thousands, millions, billions. It's a huge number. That's why it's called a polymer, many units. This unit, repeating unit, is repeated over and over and over. By breaking this, pretending to break, this other ester, ester bond, I'm also showing what it was made from, the monomers. If I copy these out, then I can see what they're made from. So I'm going to write CO, CH2, CH2, CO. Oops, delete that. I'm also going to write O, CH2, O, and then this funny thing here. Okay. Now, none of those look very complete, do they? But remember I said it was a condensation polymer. Water, or HCl, has been removed from this. Organic compounds with oxygens could actually be a diol, so they could have hydrogen here. And that would now be a valid organic chemical, organic compound. So that would indeed be one of our monomers. Over here, if it's water, well, I've already got H, so let's put the rest of it there. H2O. You see the H2O there? Condensation. Had this removed to join these together to make this polymer. HOH. Now, that's not a very effective way to make it. What you'd find is that usually it would be HCl that is driven off, because the acid chlorides, and you put Cl in brackets above these, the acyl chloride versions would actually be more spontaneous or a quicker reaction. So the monomers for this are N amounts of this plus N amounts of this, so massive numbers of each of them, to make this polymer. So one of the skills you need to be able to do is, one, identify the repeating unit. Break the first ester in half, wait until you see that point and put another line there. Square brackets and a little lowercase n. Then, once you've identified the repeating unit, which is only an achieved level thing to do, you then need to identify the monomers that were made. Alternatively, you might be given the monomers and be asked to draw a section of the polymer and identify the repeating unit in that. So you might be given these two and be asked to draw this. And the way that we do it, you take the OH or Cl off your diacyl chloride or dicarboxylic acid, and you take the H's off the diol and you just stick them together. So you just draw them next to each other, knowing that this is going to be your ester group that you see in the middle here. Alright? If you drew the mirror image of this, so you drew that one first, of course it's correct. It's a monomer, a polymer, it keeps going. So it doesn't matter where you take your section from. So that's the first skill. The other skill you might be asked is to identify the product if it was hydrolyzed under acidic or alkaline conditions. This is just going back to what we've already learned about esters, and that if it was under acidic conditions you get these made. But if it was under alkaline conditions, this wouldn't be the dicarboxylic acid, it would be the conjugate base version of it. So those hydrogens would be missing under alkaline conditions, and there'd be a negative charge on each oxygen. I'm going to put them back though when we photograph them now. No, these would still have their OH on them, but remember if it's alkaline conditions, then it's hydroxide you're adding, so OH. The H goes on there, and the O goes on there, and that's all you've got left over. That's all you've got. Okay? So it'd be the sodium salt or the potassium salt or something like that. Okay. So that's basically polyesters. Remember to apply everything you've learned about esters to the hydrolysis of them and the formation of them. Okay, so the conditions for those are the same. Needing there to be a catalyst and that sort of thing, unless you make it from the acyl chloride. The other type we've got are polyamides. And again, same thing, we should know what we're looking for. So in our polyamides, we're actually looking for a secondary amide group. So we're looking for this, or the mirror image of it. Okay, so we're looking for a secondary amide inside it. So again, look, I'm going to use the same structures, but just put a different one inside it. So you'll often see it done with the H sticking up and sticking down. Okay, so the same idea. We look for our amide groups, and we can see one here, one here, one here, and one here. We take the first one, and again we break it in half. We know what we're going to do, so let's just automatically put a square bracket around it. Then we wait until we see this pattern that I see here repeated, and I see it repeated here. So I break that amide in half and put my lowercase m next to it. I now have identified my repeating unit, so I now have got my achieved basically. Then I take the amide that's in the middle of it, there it is, and I'm just going to put a dotted line through it. Again, I copy out these as my monomers. I just realised the mistake that I've made in both of these, but I didn't pick up. Sorry, it's showing CH there. Apologies on that. Okay, now, those are the monomers, those two there. They would be combined to make this, or the acyl chloride version of this. However, if I was to hydrolyse these, we would never get both of them made. Under acidic conditions, this one was made, and this would have NH3 plus and NH3 plus on it. If it was under alkaline conditions, this one would be made, but this would not have these two hydrogens, just like in the alkaline conditions over there. So remember to apply what you've learned for amides to the hydrolysis of polyamides. Remember what you've learned up there, hydrolysis of esters, when looking at the hydrolysis of polyesters.